Bismillahirrahmanirrahim. Hello everyone. I hope you are all fine. I welcome you all in class of real analysis by Robert G. Bartle. In today's lecture, we will discuss a very interesting, very nice problem. This is actually example 2.2.6 D part. In this example, we have given a function f of x is equal to 2x square plus 3x plus 1 over 2x minus 1. And this function is defined for all values of x lies between 2 and 3. We have to find a constant m such that the absolute value of f of x is less than or equal to m for all x satisfying this interval. I will solve this question by using two methods. One of the method is given in this book by Robert G. Bartle, and the second one is an alternative solution given by me. So let us firstly discuss the method given in this book. We want to find a constant m with f of x absolute less than or equal to m. So our function f of x is this for every x belong to closed interval 2 to 3. Robert G. Bartle says we will work on numerator and denominator separately using only elementary inequalities. As it is given that our x lies between this interval, it means the absolute value of x is always less than or equal to 3 because the larger number in this interval is 3. So x absolute is always less than or equal to 3. Now using triangle inequality for numerator, this is my numerator 2x square plus 3x plus 1. So by using triangle inequality, I can split these terms into three terms as 2 into absolute of x square. But you know absolute of x square is equal to square of x absolute. So this is first term plus 3 into absolute of x plus constant 1. As x absolute is less than or equal to 3, so we can replace each of this absolute value with x is equal to 3. So when you replace the square of absolute with 3, it will be less than equal to 3 square. Replace x absolute with 3, this becomes 3 into 3 plus 1. So now by adding these all of this term, this becomes 28. So numerator is bounded by 28. For the denominator, our denominator is 2x minus 1. For the denominator, 2x minus 1 is positive for all values of x belong to 2 to 3. For example, if you put here x is equal to 2, the first value is 4 minus 1, this is equal to 3. And whenever you increase x from this interval, this function is a linear function, 2x minus 1, so it will be increasing function. So that's why 2x minus 1 is always positive at this interval 2 to 3 and attains its minimum value at x is equal to 3. The minimum value of 2x minus 1 over this interval 2 to 3 is 2. So we can write 2x minus 1 absolute is equal to 2x minus 1. How? Because 2x minus 1 is positive, so the absolute value of 2x minus 1 is equal to positive 2x minus 1. Now replacing x is equal to 2 here, we have 2 into 2 minus 1, this is equal to 3. So 2x minus 1, absolute value of 2x minus 1 is always greater than or equal to 3. By taking reciprocal, we have 1 over 2x minus 1 is always less than or equal to 1 by 3. Multiply 1 and 2. This is my inequality 1 and this is inequality 2. When you multiply these, both of these inequality, this becomes 2x square plus 3x minus 1 over 2x plus 1. 2x minus 1 is absolute less than or equal to 28 by 3. So thus one simple choice of m is 28 by 3. In this example, we have to find a constant m. So one of the constant m is 28 by 3. Now, one of the natural question that you may ask here, for the numerator we have find the maximum value. We have put x is equal to 3, the largest endpoint of this interval. And in case when we find the numerator, then we are finding the minimum value of this function 2x minus 1 by substituting x is equal to 2, the smallest point of this interval. Why this is difference? Why we are finding the maximum value of the denominator, and in case of why we are finding the maximum value of numerator, and in case of denominator we are finding the smallest value or minimum value? This answer is simple. Suppose we have a fraction like 7 by 2. I want to find its maximum value whenever we change numerator and denominator at the same time. Suppose this is a constant fraction, its answer is 3.5. When you change denominator, I decrease 2 to 1. Now answer is 7. If again I decrease this denominator 1 to 0.5, this becomes 14. So if you want to find the maximum value of this whole fraction, then you will increase or maximize the numerator as much as possible, and in this at the same time you will decrease the denominator as much as possible. So that's why we are finding the maximum value of numerator and the minimum value of the denominator. In this case, the whole fraction will have the maximum value. So this method is given in this book by the author. Suppose in this question we have to find the least and the smallest and the largest possible value of m over for this interval 2 to 3. For this you can use this method. Here f of x is equal to 2x square plus 3x plus 1 over 2x minus 1. If we find its derivative, first derivative, then you have 4x square minus 4x minus 5 over 2x minus 1 whole square. This derivative is always positive for this interval. The first derivative is positive. This means f of x is an increasing function over closed interval 2 to 3. Increasing mean whenever you increase x, your function f of x will increase. Further, extreme value theorem guarantees that f of x attain its maximum and minimum value over the closed interval 2 to 3. Now we find m. Given function, the absolute value of f of x is less than or equal to m. Our function is f of x this. Firstly, it may be noted that m can never be negative, because the left hand side, this side is an absolute value, and absolute value is always greater than or equal to 0. It means, and this non-negative value is less than some real number m. It means m cannot be negative because the left hand side is always non-negative. So it means your m is always positive. Now I am sharing a method to solve an inequality that I have already shared in my previous lecture. We find, say this is my inequality number 1. We make its associated equation. Associated equation can only be obtained just by replacing this less than or equal to sign with exact equal sign. So this becomes 2x square plus 3x plus 1 over 2x minus 1 absolute equal to m. Now by expanding absolute, we have two cases, plus minus m. Case number 1. If 2x square plus 3x over 2x minus 1 is equal to m, by multiply on both sides by the 2x minus 1, we have this equation, and by rearranging these terms, I have a quadratic equation this. As it is given that then quality 1 is satisfied for all x belong to 2 to 3, take x is equal to 2, an arbitrary point in this interval. We can choose any point from this interval, substitute it into 2 here. So whenever you put x is equal to 2 here and find m, you can find m is equal to 5 here, and this is nothing, this is actually the value of f of 2 here. If you exactly put f of 2 here, x is equal to 2 here in this question, you can find f of 2 is equal to 5. So my m is equal to 5. Similarly, if we take x is equal to 3, in other words, if you find f of 3, then your m is 28 by 5. 28 by 5 is 5 point something. So here m is equal to 5 is the least value of m for which 1 is satisfied. And over over this closed interval, m is equal to 28 by 5 is an upper bound of f of x absolute. Further, you can notice that any real number greater than 28 by 5 can also be taken as the value of m, because condition is that we have to find a constant m for which f of x absolute is less than or equal to m. So m is equal to 28 by 5 is actually, this is the supremum of this function. So any value which is greater than or equal to 28 by 5 will be an upper bound of this value. For example, if you take 6, then it is correct. In case when 2x square plus 3x plus 1 over 2x minus 1 is equal to minus m, because when we open this absolute, there are the two cases, plus minus m. But this is not a valid case, because this side is always greater than 0. This is always greater than 0. How this is greater than 0? If you substitute any value from this interval, this is always positive, and also m is positive. So this is not possible that this function is equal to some negative real number, because m is positive but minus m, this will be a negative number. So this is not a possible that your function is less than some is equal to some negative real number. So ignore this case. So by using this method, you can find the value, the largest and the smallest. In other words, supremum and the infimum of this function. And according to Robert G. Bartle, you can find a constant value of m which is equal to 28 by 5. But this 28 by 5 is not exactly the supremum of this function. So I hope now you have a clear understanding of this problem. Inshallah, in the next lecture, we will discuss the concept of real line. So if you find this video helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.